So the first rule that we'll talk about is called the addition rule. And with the addition rule, the first thing I want to bring up is this term here, this phrase, mutually exclusive events. That means whenever two events have no outcomes in common, okay? And on a Venn diagram, whenever we draw two events, if the two events do not overlap, then we say that these two events are mutually exclusive or disjoint, either way, okay? And whenever we have disjoint events, and we're looking at the keyword here, there's a keyword that's associated with the addition rule, or we have a formula. The probability of A or B is equal to the individual probabilities added together. This we use if A and B are disjoint or mutually exclusive, okay? So what I want to look at in this example here, okay, example 1 shows total number of rooms in a housing unit, okay? So what we did was we counted the total number of rooms, whether they're bedrooms, kitchen, bathrooms, living room. We counted the total number of rooms in this in the housing units. And what we're looking to do is we're looking to find the probability of randomly selecting a house with a total of 3 or 4 rooms. And notice that we have a keyword here, the word or. So when it comes to the keyword or, okay, so we have to ask ourselves, are these events in this empirical data, okay, disjoint? Okay, because we have a formula, if these events are disjoint, then we can take individual probabilities and add them together. So the question is, are the total rooms in a housing unit disjoint? The answer is yes, because if a house or if a home has a total of 3 rooms, there's no way they have a total of 4 rooms, okay? So these events are disjoint. So here we're looking to calculate the probability that a house has a total of 3 or 4. And what we're going to do is we're going to actually define these as events. Suppose this is event A. This is event B. Okay. Then notice what we have. We have the probability of A or B. Okay. By formula for mutually exclusiveness, okay, here we can use the disjoint formula, probability of A plus probability of B. Okay. So here we take probability of A plus probability of B, and keep in mind what the event A is defined as. A is a total of 3 rooms. So we look at the empirical experiment here, total of 3 rooms has a probability of 0.093 plus the second event B, which is the 4 rooms. So here when we look at this, 0.176. Okay, so we have 0.093 plus 0.176. Here we'll take the calculator and add these together. We should get about 0.269 or so. But that's how we can use this keyword or in order to find the probability of 2 events joined by the word or. Okay, joined by the word or. And I do want to make a comment on B and C. I'll leave these as exercises, but I do want to make a comment of what these mean. For B, you have the phrase at least 7 rooms. Okay, so here the way we can translate this, at least 7 rooms, means that you have 7 or 8 or 9 or more. Okay, and notice how the data it concludes with the 9 or more as the last event here. So if I call this event A, event B, this entire thing event C, then we have the probability of A or B or C. And it works the same way with 3 disjoint events. By the mutually exclusiveness, we can take probability of A plus the individual probability with B plus the individual probability of C. So keep in mind, A this time is the 7 rooms, okay? You have a probability, plus the probability of B, where B is the 8 rooms, and then C is the 9 or more rooms, okay? And if you take part C the same way, at most 3, well, that means that we have 1 or 2 or 3. And notice that we're introducing these keywords or, right? And since we have a formula for or, as long as these events are disjoint, we can use that formula. So once again, we call this event A, event B, event C, and now we can add the individual probabilities together.